Welcome back to the deep dive. Today, we are wading into a rivalry that honestly feels less like standard corporate competition and more like a profound philosophical statement.
It really does. It's a statement about the future architecture of work, of intelligence, and you could even argue of capitalism itself.
That's a big claim, but I think the sources back it up. We've pulled together a whole slew of extensive articles and reports, all from late 2025, and they paint this picture of just an incredibly intense, rapidly accelerating AI arms race.
And the core of this deep dive for us, for you, is to understand how Elon Musk is trying to achieve what you can only call AI supremacy. And it's not through a single software breakthrough.
No.
It's through total, aggressive, vertical control over the entire intelligence stack, from the sand to the solution, as they say.
Okay, so let's unpack this. It is a monumental undertaking. We are looking at Musk's most audacious provocation yet, and that's saying something. It's this fully integrated ecosystem under the banner of XAI.
Right.
And the central conflict, the name that gets all the attention, is what he's dubbed Macrohard.
It's a perfect encapsulation of the whole thing.
It is. This is not just another competitor. It feels like a living, breathing thought experiment made real, and it's aimed squarely at the titans of the software world.
Precisely. And so our mission today is to really analyze this interconnected system piece by piece. There are four main parts.
Okay.
First, you have the strategic ambition, the corporate shell, which is Macrohard, that's the organizational redesign. Then you have the massive physical engine that powers it all, the compute infrastructure they're calling Colossus.
Furnace, basically.
The gigawatt furnace, exactly. Third is the cognitive structure, the intelligence architecture. That's all coming from Grok's multi-agent systems. And then finally, holding it all up, the foundation is the custom-built hardware, the X1 custom silicon.
So it's a closed loop. Each part is designed to feed the others for, I guess, hyperspeed iteration.
That's the goal. It's a complete vertical stack. You're going from the specific chip designed to run the model all the way up to the product strategy and the very structure of the company itself.
That really is sand to solution. It's a level of integration we just haven't seen before, not on this scale.
Well, and the strategic insight, the belief that underpins all of this massive capital expenditure is this simple phrase, compute is destiny.
Right.
And if you believe that, then you're witnessing a fundamental structural shift. We're moving away from traditional human-centric software companies.
With all their meetings and their costs and delays and politics.
All of it. And we're moving toward organizations that are designed from the ground up to be autonomous, AI-run organisms. So this deep dive really is about analyzing the blueprint for the future architecture of power and, well, knowledge production.
Okay, let's start with the name that launched, 1,000 satirical tweets. Let's start with Macrohard. Macrohard. I mean, you have to hand it to them. It's tongue-in-cheek, it's undeniably provocative, and it immediately telegraphs the target. There's no ambiguity.
None at all. And it's such a classic Musk move. He has built his career on aggressively challenging incumbents in every sector he enters.
Absolutely. SpaceX took on the entire entrenched government space industry. NASA, Lockheed, Boeing. Tesla went straight at Detroit's manufacturing discipline.
And won. So Macrohard is just the latest and maybe the most direct challenge to the entire software world. And it does it by explicitly lampooning Microsoft's decades of dominance.
The name is just... It's strategically brilliant, I think. It works as a joke, but it's also this high-stakes manifesto.
It is. It forces every journalist, every competitor, every analyst to immediately frame this new thing against the existing giant, Microsoft. So the project was publicly announced on August 22, 2025, operating under that larger XAI banner.
And crucially, the way they framed it wasn't, we're building better spreadsheets, or we're making a faster browser.
Not at all. The stated ambition, and this is the key, is to build a modern software giant operated and scaled almost entirely by artificial intelligence.
And that is the distinction. That's what elevates this beyond just, corporate competition.
Right.
This isn't about using fancy AI tools like Copilot to help your human engineers and managers.
Yeah.
It's about replacing the entire traditional human hierarchy. The layers of management, the product owners, the QA teams, HR, all of it. Replacing it with an autonomous, synthetic intelligence hierarchy.
Exactly. And if we look at the historical context, the sources we've read repeatedly call Microsoft the cathedral of human-built software capitalism.
Oh, this cathedral.
Yeah, a cathedral erected over decades of human coordination and bureaucracy and incredible organizational discipline. So Macrohard is Musk's attempt to summon an autonomous AI swarm to build a rival cathedral.
But a synthetic one. A hyper-efficient rival built faster, cheaper, and fundamentally without human coordination as its foundation.
And that's the direct philosophical challenge. It questions the entire premise of human coordination in knowledge work.
So Macrohard really is a philosophical question wrapped up in a corporate structure. If your company's main output is purely knowledge work, coding, debugging, documentation, strategy, and not making a physical thing,
Right.
then why should humans be central to that coordination at all? Why tolerate the expense and, frankly, the slowness of human bureaucracy?
That is the core doctrine driving this entire project. Musk stated it pretty bluntly. He said Macrohard aims to be, and this is a quote, a company that can do anything short of manufacturing physical objects directly, but will be able to do so indirectly.
Okay, indirectly. Let's unpack that because that's a profound implication.
It is. So think about it this way. Macrohard might not build the car itself, but it could design the factory that builds the car. You could write all the robotics code. It could optimize the entire global supply chain and manage all the logistics.
Leaving only the final physical execution, the actual bolting together of parts, to external contractors or robots.
Exactly. Software companies, by definition, their primary job is coordinating knowledge work. So if you can remove the need for massive human coordination and all that bureaucracy, you fundamentally change the economic structure of what a firm even is.
And that brings us to some really foundational economic theory, doesn't it? The famous question posed by the Nobel laureate economist Ronald Coase.
Yes.
Why do companies exist in the first place?
That is the crucial historical connection here. Coase's whole argument was that firms exist to minimize what he called transaction costs.
Transaction costs. Let's define that for everyone.
Sure. So transaction costs are all the costs associated with human interaction and dealing with the external market. It's the cost of finding partners, negotiating contracts, enforcing quality, managing ambiguity, coordinating tasks.
It's the friction.
It's all the friction. So when Microsoft hires 10,000 engineers and product managers and HR staff, those salaries, all those meetings, the political compromises, the bureaucratic delays, all of that is the transaction cost of scaling human coordination.
So Macrohard's core economic thesis is that advanced AI agents, specifically Grok's multi-agent systems, can do all of that complex coordination, the recruiting, the code review, the strategy alignment, financial analysis.
Everything.
And they can do it at near zero marginal cost and at, well, near infinite speed.
And that thesis just instantly dismantles decades of organizational economics. It collapses the entire model.
Because traditional organizational scale, that bureaucracy, it exists because human coordination is expensive and it's slow.
Right. So if Macrohard succeeds, the organizational scale advantage that incumbents like Microsoft rely on, their ability to coordinate tens of thousands of developers around the globe, that's not just neutralized.
It becomes a liability.
It becomes a massive liability. AI replaces the bureaucracy, and you get this dramatic compression of software creation costs and time to market. Your scale suddenly makes you slow and expensive.
I find that framing just absolutely compelling. The thought experiment made real, designed specifically to optimize away the human element. So what does this synthetic organism, what does it actually look like structurally? If it's not a traditional firm, what's its architecture?
The vision for Macrohard is as a synthetic organism. It's a fluid, constantly evolving network that's powered entirely by Grok's multi-agent architecture.
So not a hierarchy chart on a wall somewhere.
No, not at all. Think of it more as a decentralized network of specialized AI agents, and they're designed to dynamically self-organize. They can scale up resources for a specific task and then decommission themselves once that task is complete, all of it happening without any traditional management overhead.
Okay, so what specific functions are we talking about delegating to these synthetic agents? We're not just talking about writing code snippets here. We're talking about replacing entire human departments.
The ambition is truly end-to-end. It covers the entire software lifecycle and the corporate operation. The bet is that advanced AI can handle these functions autonomously. So number one, coding and debugging. Writing, self-testing, and deploying production-ready code in multiple languages.
Okay, that's the obvious one. What else?
2, documentation and enterprise tooling. Autonomously generating all the necessary internal and external documentation alongside any custom internal tools needed for operations.
So it builds its own tools to manage itself.
Exactly. 3, QA, DevOps, and security. So continuous monitoring, automated deployment management, and real-time triage of security vulnerabilities and bugs as they happen.
And the fourth piece is the big one, the strategic one.
It is product strategy and forecasting. This means the system can consume vast amounts of market data, competitive intelligence, user feedback, and then dynamically adjust product roadmaps and strategic goals based on purely objective metrics. No human bias.
So in this model, the human role shifts completely. You're no longer a creator or a manager. You become a high-level supervisor. You're the translator between this autonomous organization and the messy human world of law and finance and customer behavior.
Precisely. Humans become the essential input layer and the external interface. You define the abstract goals, you make sure it's legally compliant.
Correct.
The AI organism is the workforce, it's the mid-level management, it's the internal operations. The humans are just the shepherds guiding this synthetic entity.
And it sounds like they're wasting absolutely no time turning this high-level, almost science fiction abstraction into cold, hard execution. What does the progress timeline look like as of, say, December 2025?
The movement from concept to engineering reality has been, well, incredibly fast. It reflects that imperative of velocity we see across the entire XAI project.
Right.
The public announcement was August 22nd.
Right.
By September 2025, so just weeks later, XAI began this active, very targeted recruitment for extremely specific low-level systems roles.
Right.
They weren't hiring product managers.
What are we really looking for?
Deep expertise in sandbox execution environments, in Rust, in Linux kernel programming, and custom hardware integration.
Okay, that is a huge signal. That tells you they are not building on top of existing cloud platforms like AWS or Azure or using standard operating systems. This is a metal-up build. They're creating a bespoke operating system for the AI organism itself.
That is the crucial insight. You get it. They are architecting the native operating environment from the absolute ground floor up. So as of December 2025, while Macrohard has confirmed it will be, quote, stiff competition, there are no commercial products yet.
The focus is still internal.
Rigorously internal. They're building and stress testing the internal swarm architecture, securing those critical low-level systems engineers, and establishing the communication protocols between all the Grok agents.
So when does the industry actually expect to see Macrohard move beyond this internal development and launch its first real product?
The consensus among insiders is that 2026 will bring the first live demonstrations of autonomously built systems.
And these probably won't be consumer apps, I'm guessing?
Unlikely. They're more likely to be complex self-managed products, things like enterprise tools, foundational cloud services, or maybe even core OS-level components. This will serve as the essential proof of concept, the demonstration that this synthetic self-managing organism is actually viable.
But this has to invite massive skepticism. I mean, the history of tech is littered with failed attempts at total automation. Can intelligence truly replace organization and that messy human element?
Oh, absolutely. And that is the core debate that is dominating all the tech analysis right now. The critics have valid and, frankly, very compelling points. The main one is intelligence is not organization.
Right.
They question if an AI organism can truly handle the messy, intuitive political reality of human organizations.
Yeah.
Can an AI agent, no matter how advanced, successfully navigate a complex international legal minefield?
Or can it negotiate a partnership deal that hinges on mutual human trust? Can it understand the deeply irrational nature of customer psychology?
Or even more fundamentally, can it handle true creative synthesis? Writing code is, at the end of the day, a solvable problem, but deciding what matters.
Yes. The strategy, the timing, the branding, the culture, the taste, the things that make a product really connect with people, that's what human-run firms are supposedly good at. Software is often about culture and trust, not just flawless logic.
That's the persistent friction point, and it's a valid one. However, if Macrohard succeeds, even just partially, in automating the cost structure of software development, the disruption potential is staggering.
We're talking about the potential for a near-total collapse of software creation costs.
A collapse in costs, continuous AI iteration leading to a massive compression of time to market, and that organizational scale advantage held by the incumbents being completely neutralized.
And crucially, that collapse in development costs, it gives leverage to everyone else, to startups, to governments, to small enterprises. They could suddenly access enterprise-grade tooling affordably because the massive development cost base has just been decimated by automation.
It creates a massive flattening of the competitive landscape.
Yeah.
Musk's summary of the ambition is pretty pointed. The project aims to be profoundly impactful at an immense scale. Macrohard is forcing the industry to confront the single most uncomfortable question.
Which is?
If AI can efficiently build self-sustaining software companies, what happens to all the ones built by humans who rely on expensive, slow coordination?
It's a radical redefinition of the economic unit of production itself. But, as we established, philosophical manifestos don't train trillion-parameter models.
No, gigawatts do.
Gigawatts do. And this entire synthetic organism, it relies on a massive, relentless, proprietary source of energy and computational power, which brings us to the physical core of this entire operation, Colossus. Okay, so if Macrohard is the brain, Colossus is the beating heart. Or maybe a better analogy is the gigawatt furnace that provides all the essential energy. The core philosophy here, according to Musk, is just non-negotiable in this current AI epoch. Algorithms and data are necessary ingredients.
But compute is destiny.
Compute is destiny.
That single statement really encapsulates the strategic urgency that's defining this entire project. Modern AI breakthroughs are getting to a point where they're not limited by architectural cleverness or even revolutionary data sets anymore.
They're limited by physics.
They're limited by physics, by physical throughput, data movement velocity, and sheer training scale. So to compete with, or more accurately, to surpass giants like OpenAI, DeepMind, and Anthropic, xAI decided it needed its own industrial-scale intelligence factory. They refused to be constrained by renting compute or adhering to someone else's timeline.
And that's why Colossus is described in the sources as both a strategic weapon and a digital foundry. It is the physical, hypercapitalized manifestation of xAI's ambition to control the production rate of intelligence itself.
And the defining feature of its creation was, without any doubt, velocity, just raw speed. Colossus was strategically located in Memphis, Tennessee.
Why Memphis?
Primarily for its abundant and relatively cheap power access from the Tennessee Valley Authority, favorable logistics with FedEx's hub right there, and available land parcels. But the speed of construction was genuinely shocking. People involved described it as superhuman.
Let's focus on that speed, because the timelines here just defy all industry norms. How in the world did they achieve the construction and deployment of Colossus IA in just 122 days?
So Colossus IA, that's the initial phase. It consists of a huge cluster of 100,000 Nvidia H100 GPUs.
100,000.
100,000. Now, bringing a facility of that complexity online in just 122 days is completely unprecedented. For comparison, similar hyperscale data centers routinely take 12 to 24 months, sometimes longer.
So how did they do it?
They used an extreme parallel construction methodology. They leveraged modularity and prefabrication to a degree that nobody has really done before. Key components, so power distribution units, cooling blocks, networking racks, they were all built and tested off-site in parallel.
So they were building the pieces in different factories at the same time.
Exactly. And then they were rapidly shipped and assembled on location like they were industrial-scale building blocks. The reports also suggest a really aggressive prioritization. They focused on getting power and cooling functional first, sacrificing some long-term cost optimization for immediate operational velocity.
And that velocity, getting a 100,000 GPU cluster online in 4 months, that is the organizational defiance of conventional timelines. That's what gives xAI its competitive training advantage.
It's everything. If your rivals take a year to deploy what takes you 4 months, you are constantly ahead on the iteration and training curve. You just get more shots on goal.
But they didn't stop at 100,000 GPUs. That was just the start. Now they're scaling up to Colossus second, which is a jump of, well, exponential magnitude.
Colossus Second marks the true exponential escalation. By mid-2025, xAI had acquired a monumental 1 million square foot warehouse and secured 100 acres for the expansion. This wasn't just an incremental upgrade. This was them crossing the crucial gigawatt Rubicon.
The gigawatt Rubicon, that term itself just captures the scale. Can you quantify that? What does a gigawatt of power consumption mean for our listeners?
I can try. Colossus Second is designed to be the world's first serious attempt at a gigawatt-scale AI training cluster. The power target scales from an initial 250 megawatts up toward approximately 1.2 gigawatts.
1.2 gigawatt.
With long-term plans for even higher levels across the whole complex. To put that into perspective for you, 1.2 gigawatts is roughly the output of a full-scale nuclear power plant.
Wow.
Or the entire power consumption of a major metropolitan area. This facility is effectively an industrial AI city. It requires sovereign-level energy infrastructure to even exist.
And the GPU targets, I assume, match that immense power appetite. We're moving into the realm of truly astronomical chip counts here.
They do.
Yeah.
The current plans include capacities ranging from 550,000 GPUs up to over 1 million. And they're incorporating the latest next-generation GB200 and GB300 Blackwell architectures from Nvidia.
It's a scale that's really difficult to grasp.
It is. The long-term projection that xAI has touted is an equivalent compute power of 50 million H100 GPUs over a 5-year window. This is the scale you need if your goal is not just to compete, but to potentially monopolize the cognitive output capacity of the entire planet.
So let's detail the components that make this AI blast furnace possible. It's not just about the chips, right? It's the complex systems engineering for networking, cooling, and power management that allows the scale.
Absolutely. The architecture is a marvel of cutting-edge systems engineering.
Uh-huh.
Every single component is optimized for data and power flow. So first you have the core cluster,
Hmm.
over 100,000 H100s at the start, expanding to potentially 1 million next-gen units.
Okay.
Second, the networking backbone. They're using Nvidia's Spectrum-X Ethernet. This is a critical distinction. Standard data center networking would just become a crippling bottleneck. It couldn't handle the massive, continuous, low-latency data streams you need for training models across hundreds of thousands of distributed chips. Spectrum-X is optimized precisely for this kind of AI workload.
And storage. To feed 1 million GPUs, you need an ocean of data.
You need exabyte-scale storage systems. We're talking data pools holding millions of terabytes, constantly feeding the colossal datasets, including that real-time pipeline from X. The speed at which you can move this data has to be immense to keep 1 million GPUs constantly operating at peak efficiency. You can't have them sitting idle waiting for data.
And then there's the heat. A gigawatt of compute must generate an astronomical amount of heat. You can't just cool this with fans.
It's impossible. It requires massive specialized infrastructure. They're relying on industrial liquid cooling systems. Some of these are described in the reports as being the size of school buses.
School buses.
Yes, circulating vast volumes of coolant directly over the chips. Liquid cooling is mandatory to achieve the necessary density and to manage the heat output efficiently.
But the truly novel component here, the one that feels like it's pulled from another one of Musk's companies, is the power system. It seems designed for autonomy and negotiation.
It is. The integration of the Tesla megapacks and the gas turbines is the pivotal strategic move. It grants them grid resilience and, frankly, political leverage.
How so? What do the megapacks do?
The deployment of these massive Tesla megapacks serves as a buffer. Think of these big battery farms as an ultra-efficient currency exchange for energy. They store cheap off-peak power from the grid, and then they can release it instantly to handle the massive, sudden load spikes that happen during intense model training. It's a process called load shaping.
So it smooths things out.
It stabilizes their internal demand, and it protects the external grid from their massive power draws.
And the on-site gas turbines, that gives them independence.
That's the other piece of the puzzle, exactly. This allows Colossus II to negotiate with the grid as an equal. They can dynamically throttle their demand. They can shift instantaneously to their own internal generation during regional peak usage, or they could even potentially sell power back to the grid during stability events.
So they're not just a customer of the power company, they're a peer.
They are a peer. This dual-source capacity makes the facility incredibly resilient, and it gives xAI tremendous, unprecedented leverage with local utility providers, which is a necessity when you're drawing 1.2 gigawatts of power.
This is truly civilization-scale infrastructure. And the physical ecosystem that's springing up around the Memphis facility seems to reflect this scale, especially when you look at resource consumption like water.
It does. The project's water requirements, which are essential for those massive liquid cooling loops, necessitated an extraordinary investment. An $80 million water recycling facility built right next to the campus.
$80 million just for water.
And this facility incorporates what is reported to be the world's largest ceramic bioreactor. It's designed specifically to dramatically reduce freshwater usage by constantly recirculating the cooling water.
That detail about the ceramic bioreactor is fascinating. Why that specific technology? What's the advantage of ceramic?
Ceramic filtration provides vastly superior robustness and pore consistency compared to the traditional polymer membranes you'd find in other systems. And that consistency is essential when you're dealing with the massive volumes of water that have to remain absolutely pristine for these highly sensitive industrial liquid cooling systems.
So it's a necessary investment.
It is, because a 1.2 gigawatt data center would otherwise draw an unsustainable amount of water from local municipal sources, which would create all sorts of political and environmental friction. This is about de-risking the operation.
And the planning documents suggest this isn't even the final scale.
No. Internal documents anticipate over 2 gigawatts of total IT capacity across the broader ecosystem. That signals planned expansion corridors extending geographically from Tennessee into northern Mississippi. So this isn't a single facility. It's an emerging regional industrial complex dedicated entirely to the production of artificial intelligence.
And of course, we have to mention the theatrical declaration, the stunt that symbolically links this colossal physical power to the corporate ambition.
Yes. The famous branding stunt. In October of 2025, Musk revealed the plans to paint the name Macrohard, right across the roof of the Colossus facility in Memphis.
And the lettering is designed to be huge.
Large enough to be clearly visible from orbiting satellites. It's this symbolic move that forcibly links the massive physical compute infrastructure to that abstract corporate ambition. It's a clear declaration. AI autonomy is being forged right here, under our roof, and we want our rivals to see that we are physically capable of scaling beyond them.
It perfectly reinforces the strategic thesis we've been talking about. AI autonomy is an infrastructure problem. Macrohard, the company, it just remains a thought experiment without the computational spine of Colossus to power it.
That is the perfect summary. And Colossus's primary role, its day job, is training the Grok family of LLMs. But the unique advantage here is data velocity. By using real-time pipelines from X, formerly Twitter, XAI is embedding freshness directly into the training process.
Creating what the sources call a formidable moat.
It is a moat. Grok learns from the global discourse as it's unfolding, moment by moment. That gives it this powerful, real-time situational awareness that static, month-old data sets just cannot provide.
But operating at this gigawatt scale and aiming for a concentration of compute power that could potentially be, as you said, more AI compute than the rest of the world combined within 5 years, that doesn't come without some serious scrutiny, especially around security and international stability.
No, it does not. And we have to address the significant geopolitical and security risks that are inherent in building intelligence infrastructure this massive. The source reports noted XAI's reliance on large-scale Chinese manufactured transformers for the Colossus II infrastructure.
And these aren't the AI transformers. These are the big high-voltage electrical components for power distribution.
Correct, the big gray boxes you see in a substation. And relying on a geopolitical rival for those is a fascinating and, frankly, dangerous trade-off.
They're trading immediate supply velocity and probably lower costs for potential geopolitical exposure and a massive supply chain vulnerability and absolutely critical hardware.
It really highlights the extreme pressures of this AI arms race, where speed often trumps long-term geopolitical caution. But the greater systemic risk is the unprecedented centralization of cognitive power. This whole project signals that XAI is betting that sheer scale and velocity trump all other factors.
Which leaves us with the big question.
Is this leading toward an age of scientific supremacy or just an age of extreme centralization, where one single entity holds the keys to the most powerful thinking machine ever built?
Whoever owns the power owns the future. Let's move now from the raw physical power source to the intelligence engine that actually utilizes it, Grok and its multi-agent systems.
Okay, so we've established that Colossus is the factory floor. Grok, then, is the intelligence architecture being manufactured and refined inside it. And the paradigm here seems to be shifting, moving away from the LLM as a single sequential thinker, and towards the LLM as a highly specialized collaborative swarm. That's the critical conceptual leap. The limitation of traditional single-threaded LLMs is that they're prone to sequential errors. They can make a mistake early on and then build on that mistake. They're also limited by the depth of their reasoning on really complex tasks.
So what's Grok's approach?
The approach, particularly with Grok 4 and Grok 4 Heavy, which launched in July 2025, is to deploy swarms of independent agents that specialize in specific subtasks. They function like an ultra-efficient, constantly cross-verifying team.
It sounds like it's mimicking human teamwork, but scaled to an impossible degree, and I guess without all the human failings like ego and miscommunication.
Exactly. It's human teamwork, but with superhuman precision and scale. Grok 4 Heavy, which is optimized for the most advanced tasks, is designed to manage large-scale automation, complex workflows, and strategic problem-solving. Musk claims that Grok effectively spawns hundreds of specialized coding, image, and video understanding agents that then iterate autonomously within virtual sandbox environments to refine their outputs.
Can you walk us through a specific detailed workflow? How does this multi-agent system actually execute a high-stakes task autonomously and show that cross-verification in action?
Yeah, let's use a hypothetical but very realistic high-stakes Macrohard task. Let's say designing a new secure data synchronization module for an enterprise client. And this module has to meet both very low latency demands and strict European regulatory compliance.
Okay, a complex, real-world problem.
A very complex problem. So here's how the swarm would tackle it. First, you'd have Agent 1, the project manager planner. Its job is to define the task objective and break it down into all the required submodules, the API endpoints, the database schema, the encryption standard needed, and so on.
So it creates the project plan.
It creates the plan. Then you'd have Agent 2, the code arrest expert. This agent writes the core high-performance code for the synchronization logic, and it's optimized specifically for the X1 inference chip architecture we'll talk about later.
While that's happening.
While that's happening, simultaneously, Agent 3, the validator tester, spins up maybe 50,000 distinct virtual testing environments. It's running stress tests, memory leak detections, denial of service simulations against the code that Agent 2 is writing in real time.
So if it finds a vulnerability,
It automatically reports back to Agent 2 for an instant fix. There's no ticketing system, no weekly bug review meeting. It's an instantaneous feedback loop.
and what about the legal side, the European regulations?
That's Agent 4, the compliance legal agent. It scans the code and all of its accompanying documentation against the strict GDPR and local regulatory frameworks. It generates compliance reports and ensures that all the data handling protocols are integrated into the deployment schema correctly.
And finally, a deployment agent.
Yep, Agent 5, the deployment DevOps agent. It monitors the performance metrics coming from Agent 3 and the compliance reports from Agent 4. And once all checks pass, it autonomously initiates the deployment process across the cloud infrastructure, optimizing resource allocation on Colossus.
That is the power of the swarm made tangible. The final output isn't just correct code. It's inherently robust, it's optimized, and it's legally compliant because all those processes were run simultaneously and iteratively, not sequentially.
And that speed and self-correction is then compounded by the system's integration with real-time data from X. The agents are integrated with native tools and these real-time feeds, which ensures their reasoning is current, factual, and context-aware.
And that's what drastically reduces the problem of hallucinations.
It does, because any agent can cross-verify a fact against the most current global discourse available at that exact moment.
This architecture is obviously foundational to the entire vision of Macrohard. Without this swarm capability, Macrohard just remains an empty concept.
It is the functional backbone. Macrohard requires these autonomous agents to emulate entire human development teams, writing, testing, deploying, and managing code without direct human intervention. The Grok multi-agent architecture is what provides that capability. It allows the synthetic organism to truly scale itself.
Okay, let's look at the concrete tools and APIs that XAI has released to push this model out to external developers. What's the status as of December 2025?
The democratization of this swarm technology really began in December 2025 with the release of the Agent Tools API, which came alongside Grok 4.1. This API allows external programmers to craft and orchestrate their own custom multi-agent applications.
And are people using it?
Yes, we're seeing some early and pretty sophisticated examples, especially in finance. You're seeing agents that can coordinate complex research, data analysis, and even trading decisions, all happening almost instantly.
And the push into real-time voice integration, that signals a focus on immediate, practical application, doesn't it? It's not just for complex back-end tasks.
Precisely. The Grok Voice Agent API incorporates real-time, multilingual voice interaction with sub-second latency. This is crucial for environments where an instant response is mission-critical. You can speak a complex query, and the agent can spawn a sub-agent to find a specific fact, analyze it, and then integrate it into its synthesized response seamlessly while you're still speaking.
That kind of real-time capability naturally makes it applicable to high-stakes environments, far beyond just consumer chat.
That's absolutely right. The source material notes the deployment of specialized multi-agent applications for key government sectors. U.S. federal agencies are reportedly using custom Grok agents for complex logistics optimization, real-time intelligence analysis, and operational planning.
So that underscores the system's perceived reliability and versatility in these mission-critical environments.
It does. Adoption looks strong, but we do have to compare this to the parallel efforts by OpenAI, which has also been heavily invested in this idea of collaborative intelligence.
It's a fascinating dual evolution, isn't it? OpenAI's agent journey began a bit earlier with their Swarm framework.
It did, in October 2024. Swarm was an experimental, open-source, client-side framework. It was focused heavily on simplicity, agent specialization, and efficient task handoffs. Really, the foundational mechanics of how you divide and conquer a complex problem with AI.
So Swarm was the architectural groundwork. It was about teaching agents how to collaborate without the pressure of a high-stakes production environment.
Correct. And then, building on that, OpenAI released its more robust Agents SDK in 2025. This toolkit was focused on practical enterprise applications. It emphasized things like dynamic prompt generation and, very importantly, automatic vulnerability triaging.
So building in sophisticated safeguards against security issues like prompt injection, which has to be a major concern for any autonomous system.
It's a huge concern. And the research that's come out validating OpenAI systems has been highly compelling, particularly in these security domains.
Right, the Artemis framework.
The Artemis framework. Studies from institutions like Stanford and Carnegie Mellon validated this multi-agent approach. Their Artemis framework, which was inspired by Swarm, actually outperformed most human participants in penetration testing.
So it demonstrated that specialized agent collaboration can discover security vulnerabilities with greater speed and accuracy than conventional human testing teams.
It can. So what we have are two highly capable approaches, but with some subtle differences in their strategic focus.
How would you summarize the key distinctions between the Grok and the OpenAI agent systems?
I think the difference is primarily in their philosophy of scale and integration.
Mm.
For OpenAI, with Swarm and the SDK, the emphasis is on ergonomics, customization, and client-side execution. Their goal is to empower external developers to build small, powerful, specialized agents for their own use cases.
It's a toolkit.
It's a toolkit. For Grok, with its multi-agent architecture, the emphasis is on scale, deep autonomy, and that unique real-time data integration from X. Grok's primary objective is to fuel the self-sustaining organism of Macrohard. It requires massive, continuous, autonomous coordination that is optimized for its own proprietary hardware stack.
So Grok is betting that real-time relevance and just sheer compute-fueled scale are the ultimate differentiators. OpenAI, on the other hand, is focusing on building the most user-friendly, adaptable toolkit for others to use.
That's the core strategic divergence. However, the broader AI research does confirm a cautionary note here.
Which is?
Simply adding more agents isn't a reliable path to better enterprise AI systems. This really reinforces the need for smart, sophisticated orchestration, which is what both Grok and OpenAI are intensely focused on achieving. It's about specialization, communication, and verification, not just quantity.
And looking ahead, where are these agent systems ultimately driving the industry? What's the end game?
The trajectory is clearly toward what you might call AGI-level collaboration. With Grok 5 on the horizon, the expectation is that these autonomous agents will move beyond just executing predefined tasks and start to innovate and strategize independently.
So the goal is for the swarm to not just build the product you told it to build,
But to make autonomous decisions about long-term strategy, market timing, and resource allocation. This is what pushes the entire industry toward a distributed, dynamic intelligence that is truly superhuman in scope.
But none of this is possible, none of it, without the absolute, unshakable foundation of hardware. We have to now turn to the AI chip race and XAI's move toward complete vertical integration. All right, this is where the rubber meets the road, or I guess where the silicon meets the sand. The entire XAI empire, from Macrohard's economic model to Grok's iterative speed, it all rests on the premise that hardware is king. Achieving that scale, training those massive models, it depends entirely on specialized silicon that XAI can control.
This is the ultimate expression of the vertical integration strategy. Musk's rationale for custom chips, first the D1 chips at Tesla, and now the X1 for XAI, it's driven by three core non-negotiable strategic factors.
Okay, what are they?
One, addressing supply bottlenecks. The chronic, crippling limitation in the AI industry right now is the constrained supply of high-end Nvidia GPUs. Custom chips eliminate your reliance on someone else's allocation schedule.
So you get to the front of the line by building your own line?
Exactly. Two, efficiency optimization. Proprietary silicon allows for maximum hardware-software co-design. The X1 chip can be optimized specifically for the unique computational needs of the Grok multi-agent systems and Macrohard's continuous inference demands.
And the third piece is control.
Full stack control. This ensures that XAI can innovate and control the cost structure from the transistor layer all the way up to the application layer. That gives them a strategic leverage that is just unattainable by companies that are just consumers of hardware.
It's all about reducing dependence. Musk is famous for minimizing reliance on external suppliers across all his companies. And here, the immediate dependency is Nvidia, which currently holds the gold standard.
Nvidia's GPUs, specifically the H100 and A100 series, they remain the indispensable backbone of the Colossus cluster. And that's because they excel at parallel processing, which is essential for deep learning training. Their CDA software ecosystem provides this really entrenched, powerful software layer. And the new Blackwell architecture, the GB200 and GB300, that represents the current frontier.
But depending on Nvidia means you're paying a massive premium, and you're always facing those persistent supply chain delays.
Always. And that's where Google's strategy, building its own TPUs, provides the blueprint for the alternative path.
Right. Google's TPUs.
Exactly. Google's tensor processing units, or TPUs, are application-specific integrated circuits, or ASICs. It's custom-built hardware optimized specifically for machine learning workloads. TPUs excel at high-throughput matrix multiplications and low-precision arithmetic, and they offer an extremely energy-efficient solution for both training and inference. They are the proof point for the power of proprietary hardware-software co-design.
And Musk is now leveraging the internal expertise that was developed at Tesla, essentially adapting that Dojo supercomputer blueprint for XAI.
That knowledge transfer is absolutely critical. Tesla already pioneered this with the Dojo supercomputer and its custom D1 chips, which were optimized specifically for autonomous driving AI workloads. At the 2025 AGM, Musk even hinted at establishing a gigantic fab for AI chip production, targeting the next-generation AI-5 chips in 2026, potentially through a manufacturing partnership with Intel.
So this established internal silicon expertise is the foundation upon which XAI is now building.
It is, and that established competency leads us directly to the custom silicon designed specifically for Grok, the X1 chip.
Okay, let's talk about the X1. What is its architecture, and crucially, what is its primary purpose?
The X1 initiative was first announced through these highly specific job postings in July 2025 for novel AI hardware architects. The chip is codenamed X1, and we have to emphasize this point. It's fundamentally designed as an inference chip, not a training chip.
Okay, let's break down that distinction because it's absolutely paramount to understanding Macrohard's economic model, inference versus training.
Right. So training chips, like the Nvidia H100, are optimized for high-precision, intense, short-period computation. Their job is to build the model, and that requires massive data throughput and a ton of power. This is the expensive, specialized work that's performed on Colossus. Building the brain. Building the brain. Inference chips, like the X1 is designed to be, are optimized for continuous, low-power, high-efficiency computation. Their job is to run the trained model, to use the brain incredibly fast and incredibly cheaply, often distributed across various products and services.
So the massive, expensive Nvidia H100s will train the Grok models on Colossus, but the custom-designed X1 chip will be what deploys the Grok multi-agent swarm into Macrohard's enterprise tools and its various APIs cost-effectively.
Precisely. The X1 is optimized specifically for running the complex, iterative workloads of the Grok multi-agent systems. If Macrohard is going to function as a self-sustaining corporation that's running continuously 24/7, the cost of inference has to be nearly negligible. The X1 is designed to enable that faster, cost-effective deployment and operationalization of the entire synthetic organism.
What kind of advanced manufacturing process is the X1 using to achieve that efficiency?
It's being fabricated on TSMC's advanced 3-nanometer process. And that process node is the absolute leading edge of semiconductor fabrication anywhere in the world.
Why is that 3-nanometer number so critical to the performance of an inference chip?
The nanometer scale defines the size of the transistors on the chip. At 3 nanometers, you achieve the maximum possible transistor density. That means you can pack exponentially more computational power onto a single piece of silicon than older processes allow.
More power in the same space.
And critically for inference, this simultaneously increases speed while drastically reducing the power consumption per operation. For the continuous, high-volume deployment of autonomous agents, that level of power efficiency is a massive strategic advantage and a huge cost reduction.
The ultimate projection for this hardware is just staggering. I think the number was an equivalent compute power of 50 million H100 GPUs within 5 years. How are they even planning to handle the production timeline and scaling to get there?
It requires a massive financial and strategic multi-pronged approach, and it involves some key partnerships. So, XAI secured a major ASIC design and manufacturing support order from Broadcom.
Ah, Broadcom.
Yep. Leveraging Broadcom's deep expertise in custom AI accelerators is crucial for transitioning the X1 design from a blueprint into a physical, manufacturable chip.
But let's stress test this core thesis again. By relying on TSMC for the 3-nanometer fabrication and Broadcom for the ASIC design support, isn't XAI just trading a dependence on Nvidia for a dependence on this Taiwanese-US chip duopoly?
That is the essential nuanced question. And the answer is that it's a strategic dependency swap that provides significantly more control.
How so?
They are no longer dependent on Nvidia for the proprietary chip design and the allocation of that chip. XAI now owns the proprietary IP for the X1 architecture itself. They are reliant on TSMC for the manufacturing service. If TSMC's supply were constrained, they could theoretically take their X1 design to another advanced foundry like Samsung or Intel.
So it's a shift from owning the process to owning the design.
And that is a huge strategic leverage. It's about controlling the intellectual property of the intelligence architecture, even if the final production is outsourced.
So what's the timeline for getting this new hardware fully scaled?
The initial production run of the X1 is scheduled for 2026. They're targeting a preliminary run of about 300,000 units. Mass production is targeted for late 2026 or early 2027.
But that leaves a gap.
It does. And to ensure they don't lose that velocity during this transition, xAI is simultaneously raising a massive $12 billion funding round. That money is specifically to supplement their immediate Nvidia purchases until the X1 is fully scaled and integrated into the Colossus infrastructure.
And we also have to consider the global ambition that's reflected in their plans outside the U.S. This vertical integration strategy is operating on a truly global industrial scale.
Absolutely. The global ambition is immense. In November 2025, significant hints emerged about a potential 5-gigawatt AI campus in Abu Dhabi.
5 gigawatts.
5. And this campus is not just about more compute. It's strategically aimed at establishing massive, industrial-scale fabrication and deployment capacity. The intent is to produce millions of these custom chips annually, potentially by partnering with local firms like G42.
A 5-gigawatt campus suggests a massive strategic effort. Why Abu Dhabi specifically? What's the logic there?
Well, the Middle East offers massive, stable, cheap energy sources, which is essential for a 5-gigawatt facility. That's coupled with significant sovereign wealth funding and a political stability that supports these kinds of long-term, capital-intensive infrastructure projects.
So it provides geopolitical redundancy.
Crucial geopolitical redundancy and access to resources. It solidifies Musk's intent to control every single aspect of the supply chain on a truly industrial, multi-continental scale.
So the combination of Tesla's existing silicon expertise and xAI's new infrastructure, it creates this perfect closed-loop system where the hardware fuels the intelligence.
Indeed. The entire strategy just solidifies the core idea. Control the hardware. Control the intelligence. This is an investment of potentially trillions of dollars over the long term, all to buy strategic leverage and ensure these unprecedented scaling rates. It positions xAI as a major global player, capable of producing its own proprietary hardware that is optimized exclusively for its synthetic intelligence stack.
This entire deep dive has really laid out a complete, vertical, self-reinforcing AI strategy from the custom chip inference layer all the way up to the autonomous corporate structure.
Yeah.
Hashtag outro.
And if we synthesize this entire vertical stack for you, the listener, the key takeaway has to be that xAI sees AI supremacy not as a model problem.
Yeah.
It sees it as a full-stack, hypervelocity engineering problem. So we began with Colossus, the gigawatt power source.
Yeah.
That trains Grok, the distributed multi-agent intelligence. That intelligence then runs cost-effectively and efficiently on the custom X1 silicon, which in turn enables Macrohard, the autonomous AI-run organization.
Yeah.
It's a fascinating paradox when you think about it. They're building this massive, highly centralized physical infrastructure colossus in order to support a highly decentralized, self-correcting, autonomous corporate structure in Macrohard.
It's a complete inversion.
It's a fundamental challenge to the organizational structure of capitalism itself. You know, the Industrial Revolution led to factories of steel. This era is building these cathedrals of compute power.
And Musk is making a relentless trillion-dollar bet. He's betting that sheer velocity and industrial scale will trump traditional human talent, entrenched bureaucracy, and established market position. He is confident that the self-optimizing speed of the synthetic organism, fueled by its own proprietary compute, will always outpace human coordination.
And if that bet pays off, I mean, if xAI actually achieves its goal of command and compute equivalent to 50 million H100s, potentially having more AI cognitive power than the rest of the world combined within 5 years.
Then we face a profound systemic outcome, a real fork in the road. Will the sheer concentration of this unprecedented cognitive power, controlled by one entity that has removed the friction of human coordination, will that lead to the age of abundance that the proponents prophesy, where the cost of all knowledge work collapses for everyone?
Right.
Or will it simply lead to an age of unprecedented centralization, where one single organization holds the ultimate keys to the world's most powerful thinking machine? Something for you to mull over as the bulldozers in Memphis and the engineers designing the X1 chip continue their work in 2026.
A compelling and, I think, a necessary question to end on. The future of the global economic structure may very well depend on the answer to that. Thank you for guiding us through this unprecedented deep dive.
My pleasure.
We'll see you on the next deep dive.